Imagine a device that doesn't require gunpowder. A device that makes no sound when fired, cannot be detected by radar, and can travel thousands of kilometers without being spotted. In 2010, deep inside a highly secure technology plant in Natanz, engineers were facing a nightmare. Their most critical machinery, steel centrifuges spinning at astonishing speeds, was exploding. But this wasn't a normal malfunction. It was as if the machines were intentionally self-destructing. The most disturbing thing wasn't the damage caused. It was that, while metal fragments flew through the air, the engineers' screens indicated that everything was functioning optimally. The computers showed green, but the reality was total chaos. What they were witnessing was the first attack of a new era. It wasn't a missile, nor a bomb. It was a code. Its name was Stuxnet. And it was the moment when software became a weapon capable of affecting the physical world. Today we'll explore how the impossible virus was developed to achieve what no army had been able to do: shut down a secret program without firing a single bullet. Get ready, because what you'll discover today isn't just a story about hackers, it's the beginning of a new way of understanding our world. To grasp just how remarkable this story is, we must first introduce a concept known as the air gap. Imagine you have a computer that holds the planet's most important secrets. To secure it, you don't just set a password. You turn off Wi-Fi and Bluetooth and unplug the internet cable. That computer becomes an island. There is no way to access it from the outside. It is the ultimate protective barrier. The Natanz facility was a cyber fortress. It was located several meters underground, surrounded by security measures, and completely isolated from the rest of the world. There was no way a hacker could get in there, or so many thought. At that moment, the Western world faced a major dilemma. There was great concern over the technological advances in that region, and time was running out. A conventional physical attack would have resulted in a global catastrophe. So, US and Israeli intelligence agencies posed a question that altered the course of events: is it possible to hack something that isn't connected to anything? The answer was Operation Olympic Games. It was the most confidential and ambitious plan in digital history. Its goal: to develop a code that could move, hide, and cause destruction. Building something like that isn't as simple as programming a computer. For Stuxnet to work, its creators needed tangible proof. According to later studies, the United States and Israel built a duplicate facility, an exact replica of Natanz, in a covert laboratory. They purchased the same centrifuges on the black market to witness their actual failure. They spent months testing the code on metal machines until they achieved the ideal pattern of deterioration. They were designing a digital projectile that had already been launched countless times in the dark before hitting its target. If there's no internet connection, how do you introduce the virus? This is where the human factor, the most vulnerable part of any security system, plays a key role. Stuxnet didn't enter via a suspicious email. It appeared via a simple USB drive. Someone, possibly an unsuspecting employee or a duped contractor, plugged that small device into one of the plant's internal computers. And in that instant, the digital network was compromised. However, this is where Stuxnet becomes something astonishing and disturbing. Generally, a virus acts like a fire: it consumes everything it touches. It deletes files, freezes screens, and generates annoying noises. Stuxnet was not like that. Stuxnet operated like a stealthy sniper. Once it entered the network, the virus remained dormant. It stayed hidden in the digital shadows of the system. The virus's mission was very specific. It wasn't interested in photos, emails, or money. Its target was specific software from a German company called Siemens. It was specifically looking for the brains of industrial machines, devices known as PLCs. Imagine Stuxnet as an investigator walking through a huge building. It moved from one computer to another, asking, "Are you the one who controls the centrifuges in this factory?" If they answered no, the virus deleted itself to leave no trace. But when it finally found its target, the real chaos began. What makes Stuxnet a masterpiece of espionage is its great stealth. It didn't just seek Siemens software, but a precise configuration that was only in that nuclear plant. It was like a detective with the suspect's DNA. If the virus saw that the computer was not the right one, it would deactivate. It is said that the programmers included master keys, digital never-before-seen system flaws that no one knew. It was the first time we saw someone with the ability to open any digital door in the world without being discovered. The technology behind this seems straight out of a spy movie. The virus didn't just shut down the machines. That would have been too obvious, and the engineers would have fixed it in no time. What it did was far more cunning and cruel. First, Stuxnet sat back and watched. For several weeks, it recorded the machine's normal operations. It learned the proper sounds, pressures, and speeds. It's like a thief playing a surveillance recording on loop in front of the camera while robbing the safe. Then, the virus took control. It caused the machines to spin at dangerously high speeds, and then abruptly stopped them. Then it sped them up again. For metal, this is a death sentence. The machines began to vibrate, crack, and eventually fall apart. But here's the trick. While the machines were physically destroying themselves on the floor, the engineers' monitors indicated that everything was normal. The engineers watched their machines crumble before their eyes while their computers told them nothing was wrong. It was so baffling that they began to doubt themselves. They thought they had defective parts or that their technicians didn't know how to operate them. The virus wasn't just damaging metal, it was also affecting people's minds. Imagine the frustration of those engineers. They were the most capable in their nation, and suddenly, their equipment began to fail as their measuring devices indicated that everything was in order. Events of technicians were documented and questioned and pointed out for sabotage. The malware was so clever that it caused people to clash. Not only did it affect power generation, it also shattered the trust of a whole bunch of scientists who, for months, were unaware that they were fighting a hidden danger on their own computers. If Stuxnet was so flawless, why are we still debating it today? The reality is that even the most advanced program can have flaws. Stuxnet had a deadline, a point at which it was supposed to stop operating. However, in 2010, an update made it too dangerous. The virus managed to escape, leaving the plant via an engineer's laptop that he took home. The moment that laptop connected to a public network, the virus spread to the internet. Within a few days, Stuxnet was present all over the world. It infected thousands of computers in countries like India, Indonesia, and even the United States. But the curious thing is that, on those devices, Stuxnet was completely harmless. It was like a key that could only open a door in a specific location. If it didn't find the Siemens system at that plant in Iran, it simply did nothing. It was a small security firm that detected something strange on a computer. They began investigating and realized that this code was too extensive, costly, and complicated to have been created by a typical hacker. They concluded that it could only be the work of a state with unlimited resources. The world's best-kept secret had come to light. When the code was revealed, the cybersecurity field was completely astonished. The experts who analyzed the virus said reading it was like deciphering a spaceship. It was unbeatable. It is estimated that its development cost millions and thousands of hours from the brightest talents. When it was leaked, Stuxnet stopped being a secret weapon and became a guide for any malicious hacker. The ingenuity could not be hidden again, and the ultimate secret was now accessible to anyone who wanted to learn it. Stuxnet achieved what seemed impossible. It set back an advanced technology program by years without firing a single missile. However, in doing so, it fundamentally changed the landscape for all of us. Before Stuxnet, the digital realm focused on the theft of data or passwords. After its emergence, software became a tool capable of causing tangible damage. Water infrastructure, electrical systems, hospitals, nothing is truly protected if someone possesses the right code. Experts say this was the moment that changed history. A display of power we can no longer ignore. Today, the deadliest weapons are not found in warehouses, but hidden in cables under the ocean or suspended in the air, ready to execute the right command. If a simple piece of code could penetrate an underground fortress and deceive the world's leading experts, how safe are we really in our modern cities? Could something similar to Stuxnet already be waiting to be activated in your local electricity or water system? Sometimes, the greatest risk doesn't come from what makes the most noise, but from what remains hidden, waiting for the right moment to strike. Think about this: if a simple code could enter an underground base, avoid missiles, and deceive the best experts, how safe are we in our cities today? Think about it, it all depends on the computers that Stuxnet attacked. From the subway train you use, the water from your tap, to the light in your house. The digital realm is more vulnerable than many realize, and today we've barely scratched the surface. If you enjoy this kind of in-depth analysis, we ask that you support us by subscribing and giving us a like. This allows us to continue shedding light on these obscure aspects. Remember to turn on notifications so you don't miss our next case. We appreciate your support. I'm Focal Suspect, and the truth lies in the details.